Welcome to the Deep Dive, your shortcut to being well-informed. Today, we're plunging into Ethereum. You hear it mentioned everywhere, right? Often called the backbone of the decentralized internet.
That's right. It's a big one.
Yeah, so if you've heard terms like Web3 or, digital money, and maybe wondered how it all actually fits together, or even why we needed something more than, say, the early ideas like Bitcoin,
Yeah.
well, this deep dive is definitely for you.
Mm-hmm.
We're going to try and unpack this really ambitious vision and figure out what it actually means for us.
Absolutely. And it's key to understand Ethereum isn't just another cryptocurrency. Think bigger. It's designed as this foundational world computer, basically a global permissionless platform.
Permissionless.
Meaning anyone can use it, anyone can build on it, no single gatekeeper. Its whole point is to host this huge ecosystem of applications and digital agreements.
Okay.
The core promise.
Yeah.
Letting anyone build and run these things called smart contracts
Right.
or decentralized apps, dApps, without a central controller, and crucially, without downtime, without censorship.
Wow.
So our mission today is to get our heads around how that works, how it goes from just an idea to something, well, actually reshaping things.
Right. So let's start right at the beginning then, before Ethereum came along. What were the big roadblocks with the first blockchains? Why couldn't you do more than just, send digital money back and forth?
Yeah, that's the perfect place to start. So early blockchains, and Bitcoin is the prime example. They were revolutionary, absolutely. But their design was super focused, laser focused really, on being a peer-to-peer electronic cash system.
Just digital cash.
Exactly. And the limitation came down to its scripting language. It was basic. Technically, it was non-Turing complete.
Okay, Turing complete. What does that mean in simple terms?
It basically means it couldn't handle complex general-purpose programming. It couldn't run any kind of computational task you threw at it. Think of it like this. Imagine if the internet could only be used for sending emails.
Huh. Okay, useful but limited.
Very limited. It did email really well, but you couldn't build websites or apps or social media or anything else. The potential was just capped. Ethereum saw that and essentially asked, okay, what if we could build any kind of application, any kind of digital agreement on a secure, decentralized base?
So the problem wasn't the blockchain itself, but what you could build on it.
Precisely. The problem Ethereum tackled was the lack of a universal, programmable blockchain, a platform where trust doesn't come from a middleman, like a bank or a lawyer, but from code that runs automatically and transparently for everyone to see.
That makes a lot more sense. The inability to program complex stuff was the real bottleneck. So how did Vitalik Buterin, the founder, picture solving this? What was the big idea behind this world computer concept?
Well, Buterin's vision, which he laid out back in 2013, was pretty radical at the time. He proposed a single foundational blockchain, but the key difference was embedding a built-in Turing-complete programming language right into it.
So one blockchain to rule them all, kind of, but
Yeah.
programmable.
Kind of, yeah. The idea wasn't that you'd need to build a whole new blockchain network every time you had a new idea for an application. Instead, you'd have this common infrastructure, this base layer everyone could build on top of.
Okay.
So the world computer analogy really fits. Think of Ethereum like a single global operating system. It's like this incredibly powerful computer that everyone on the planet can use, everyone can program.
But no single company, like Microsoft or Apple, owns it.
Exactly. No single entity owns or controls it. It's like the whole world agreeing to share this one super reliable, uncensorable server that's, always on. He even used this metaphor, quite nice actually, of an infinite garden, a shared neutral digital space where anyone could plant their ideas, their applications, and watch them grow.
An infinite garden. I like that. It sounds very open. Okay, that vision is powerful. But how does it work? How does this global machine actually run? Can you walk us through the basics, the mechanics of processing all these different apps?
Sure. Let's break it down. So at its heart, Ethereum is what we call a layer 1 blockchain protocol.
Yeah.
An L1.
Layer 1, meaning the base layer.
Exactly. The foundational network where everything ultimately gets settled and secured. The core engine driving this world computer is something called the Ethereum Virtual Machine, or EVM.
EVM.
Think of the EVM as the universal operating system for every single smart contract running on Ethereum. It's a sandboxed virtual computer. Sandbox just means it runs in a totally isolated environment.
Why is that important?
For security. It means if someone deploys a buggy or even malicious smart contract, It can't mess up the rest of the network. It stays contained.
Got it.
And the crucial part is every instruction, every bit of code executed via the EVM produces the exact same result on every single computer or node in the network. This ensures everyone agrees on the outcome of any action.
So consensus. Everyone agrees on the state of things.
Precisely. Every transaction basically triggers what's called a state transition. It updates the network's massive shared database, the ledger, and everyone agrees on the new state after that transaction. Now, how does this huge network actually reach that agreement? That's changed significantly. In September 2022, Ethereum went through this massive upgrade called the merge. Huge deal in the crypto world.
I remember hearing about that. That was the shift away from mining, right?
Exactly. It moved from the energy-guzzling proof-of-work system, where miners race to solve complex math puzzles, to a much greener proof-of-stake system, POS.
Proof of stake. So instead of miners.
We now have validators. To become a validator, you need to stake or deposit 32 ETH into the system. Lock it up as collateral.
32 ETH, that's quite a bit of money.
It is. It represents a significant commitment. These validators are then randomly chosen to do two main things: propose new blocks of transactions and attest to basically vouch for the validity of blocks proposed by others. If they do their job honestly, they earn rewards, new ETH.
So it's not about who has the fastest computer anymore, but about who has skin in the game, who's put up collateral.
Precisely. It's more like a sort of digital jury system, maybe.
Yeah.
Validators put up their bond, their staked ETH, to prove they're trustworthy. If they try to cheat the system, like approving invalid transactions, or if they're just lazy and offline too much,
Uh-oh.
a portion of their staked ETH gets slashed.
Slashed, you mean taken away?
Yep. Destroyed.
Yeah.
Removed from circulation permanently.
Yeah.
It makes being dishonest or unreliable incredibly expensive.
So there's a real penalty.
A very real penalty.
Yeah.
And a huge side benefit of this whole shift: Ethereum's energy consumption plummeted.
Right.
We're talking about a 99.95% reduction. Massive for sustainability critics.
Wow, 99.95%. That's enormous.
It really is. Now, this proof-of-stake system secures the network, but that main Ethereum chain, the L1, it still has limits on how many transactions it can process per second, maybe 15 to 30, roughly.
Which isn't that many if you want it to be a world computer, right?
Yeah.
Exactly. That's the scalability challenge. And that's where Layer 2 solutions become absolutely critical. They are central to Ethereum's whole scaling plan now, what they call the roll-up-centric roadmap.
Layer 2s, like Arbitrum and Optimism. I've heard those names.
Those are two of the biggest ones, yeah.
Yeah.
Arbitrum, Optimism, DK Sync, Era, Starknet. There are quite a few now.
Yeah.
Think of these L2s as separate, faster blockchains built on top of Ethereum. They handle the vast majority of transactions off the main chain. They process them super quickly and cheaply.
Off the main chain, how does that stay secure then?
Good question. They do the processing off-chain, but then they bundle up hundreds, even thousands of transactions, compress the data, and post a small cryptographic proof or summary back down to the Ethereum L1. So the heavy lifting happens on the fast, cheap L2, but the ultimate security and finality comes from the main Ethereum L1 network.
Okay, so if the main Ethereum network is like a big, sometimes congested main highway, these layer 2s are like super efficient express lanes or maybe high-speed rail lines. They handle most of the traffic and just report back to the main highway authority.
That is a perfect analogy. Exactly right. They take the load off, allow for way more transactions, and bring the costs way down. And speaking of costs, there was another big upgrade called Denkun in March 2024.
Denkun, okay.
This introduced something called blobs.
Blobs, like data blobs.
Pretty much. Think of them as dedicated chunks of data space on the L1,
Right.
specifically designed for these L2s to post their summaries into, but at a much, much lower cost than regular transaction data. This innovation, part of something called proto-dank sharding, don't worry too much about the name, it slashed L2 transaction fees dramatically,
How much?
by like 90 to 100 times in many cases. It made using these L2 express lanes incredibly cheap. Average fees dropped to just a few cents per transaction.
Wow. So using Ethereum apps became much more affordable.
Hugely more affordable, yeah, provided you're using an L2, which is where most user activity is moving. And one last piece on mechanics: how you actually pay for transactions, the gas fees. That changed significantly too back in August 2021 with an upgrade called EIP 4Fee 559.
Right, gas fees, they could get really high sometimes.
They could, and they were unpredictable. EIP 1559 aimed to fix that. Now, every transaction has a mandatory base fee. This base fee isn't set by the user, it's calculated automatically by the network based on how busy it is. Here's a really interesting part.
Yeah.
This base fee gets burned.
Burned. as in destroyed, gone forever.
Yep, permanently removed from the total supply of ETH. Poof.
Huh. Why do that?
It does a couple things. It makes fees more predictable because the base fee only moves up or down gradually, block by block. And because ETH is being removed from circulation, it can actually make ETH deflationary if more ETH is being burned in base fees than is being issued as rewards to validators.
So the total amount of ETH could actually decrease over time.
It can, and it sometimes does, during periods of high network activity. There's also an optional priority fee, which is basically a tip you can add to incentivize validators to pick up your transaction faster. That tip goes directly to the validator.
Okay. Base fee gets burned, tip goes to the validator.
Mm-hmm.
More predictable, potentially deflationary. Got it. Phew. Okay. That's a lot of tech under the hood. But fascinating how it all fits together. So let's bring it back to the everyday person. What does all this mean for me? What are the tangible, practical benefits I get from this world computer?
Right, the so what question. And there are quite a few concrete benefits emerging. First, probably the most developed area is decentralized finance, or DeFi.
DeFi. Hear that term a lot, too.
Yeah. Basically, it's recreating financial services, but without the traditional banks or intermediaries. So you can lend out your digital assets on platforms like Hive or Spark and earn interest directly. Or you could borrow money using your crypto as collateral, again, without needing a bank's permission. Or you can swap different cryptocurrencies peer-to-peer on decentralized exchanges like Uniswap. It's not just about cutting out the middleman, though. It's often more transparent, accessible 24/7, and gives you more direct control over your assets. We've seen huge amounts of value locked in DeFi on Ethereum, over $150 billion by mid-2025.
$150 billion. Okay, that's serious.
Definitely. Then there's digital ownership and creativity, mainly through NFTs. Non-fungible tokens.
Ah, yes, the digital collectibles. Art, profile pictures.
Exactly. Ethereum really pioneered this. NFTs give you provable, unique ownership of a digital item. Think of it like a digital deed or a certificate of authenticity for anything from digital art, music, collectibles, even items within video games. You can buy, sell, and trade these on marketplaces like OpenSea or Blur, and you truly own that digital item recorded on the blockchain.
Okay, so verifiable digital ownership.
Yep. Next up, global cost-effective payments, especially using stablecoins.
Stablecoins, like digital dollars.
Exactly. Coins like USDT, USDC, even PayPal launched their own stablecoin, PYUSD, on Ethereum. These are pegged to traditional currencies, like the US dollar, so they don't have the crazy price swings of, say, Bitcoin or ETH itself. They let you send money across borders incredibly quickly and cheaply, often bypassing the slow and expensive traditional banking system.
So cheaper international transfers.
Massively cheaper and faster. They're seeing big players get involved too. Visa expanded support for USDC settlements directly on Ethereum. And even giants like JP Morgan, working with others, did successful tests, settling tokenized US Treasury bills across different blockchains using Ethereum infrastructure.
Wow, banks using it too.
Yeah, the lines are blurring. Another direct benefit, earning passive income. Remember those validators staking their 32 ETH?
Yeah.
Well, you don't necessarily need 32 ETH yourself. Through things like liquid staking protocols or exchanges, smaller holders can pool their ETH and participate in staking too. By doing that, you have secured the network and you earn a yield on your staked ETH, typically somewhere in the range of 4–6% per year. It's a way to earn returns while supporting the network.
So you can earn interest just by holding and staking ETH.
Essentially, yes. And here's where things get really interesting looking forward. Tokenization of real-world assets, or RWAs.
Real-world assets, like houses, stocks.
Potentially, yes. We're seeing the early stages now, mostly with financial assets, like U.S. Treasury bills, government debt being represented as digital tokens on Ethereum. BlackRock, the world's largest asset manager, launched a fund called BUIDL. It holds tokenized U.S. Treasury bills on Ethereum, and it already manages something like $2.4 billion.
So BlackRock is doing this on Ethereum.
Yep. They see the efficiency benefits. Think about it. Instead of complex, slow, traditional processes to trade bonds or shares, imagine owning a tiny digital fraction of a skyscraper or a piece of the bond, represented as a token you can trade instantly. 247 anywhere in the world, right from your crypto wallet.
Sounds kind of revolutionary, making complex assets accessible.
It really could be. It blends traditional finance with blockchain's efficiency and accessibility.
Yeah.
It's democratizing access to investments. And finally, maybe less direct but hugely important, improved user experience. The whole ecosystem knows that using crypto can still be clunky.
Yeah, wallets, gas fees, it can be confusing.
Totally.
Oh,
But big improvements are coming. There's a major push for something called account abstraction. It basically makes crypto wallets smarter and way more flexible, like your bank app, but decentralized. This could enable things like maybe an application pays your transaction fees, your gas fees for you, so you don't even have to worry about having ETH for gas.
oh, that would be huge.
Or having better ways to recover your account if you lose your password or keys, like social recovery through trusted friends or family, making it feel much more like the web apps we use every day.
That all sounds like it makes the whole thing much more user-friendly.
That's the goal. Make Web 3 feel like Web 2, but with the benefits of decentralization underneath.
This is a great point to quickly pause and remind our listeners of something.
If you're enjoying how we break down these complex projects into simple pieces and want more reviews just like this, make sure you subscribe to our channel, CryptoBox. We do all the complex research so you don't have to.
Those benefits, especially the RWA stuff and user experience improvements, sound incredibly powerful, really forward-thinking. But, okay, let's talk about the other side. With any big, powerful technology, there are always risks, right? Challenges, criticisms.
Absolutely. It's crucial to have a balanced view. Ethereum faces some significant hurdles. One persistent issue is still scalability and those high L1 fees.
Even with the layer 2s.
Well, the L2s help enormously for users interacting on the L2s. Fees there are tiny now, thanks to things like blobs. But the base Ethereum network itself, the L1, where all these L2s settle, that can still get congested and expensive during peak times. The whole scaling strategy now really hinges on the continued success, adoption, and security of these Layer 2 solutions. If L2s don't keep growing, or if issues arise there, the L1 bottleneck remains a concern.
So it's heavily reliant on this layered approach working perfectly.
Pretty much. Then there are worries about potential centralization vectors, points where control could consolidate even in a supposedly decentralized network.
Like what?
One big one is liquid staking dominance. Remember how you can stake ETH?
Yeah.
Well, a huge chunk of all staked ETH, somewhere around 27 to 33%, isn't staked directly by individuals. It's staked through a few large liquid staking protocols. Lido Finance is the biggest by far. These services are convenient. They stake your ETH for you and give you back a liquid token you can still use in DeFi.
But it means Lido, or a couple of these big players, effectively control a massive amount of the staked ETH that secures the network.
Exactly. It concentrates power. And that raises uncomfortable questions, right?
Yeah.
If too much influence rests with just a few protocols, does that undermine the core goal of decentralization?
Yeah, what if they get hacked? Or your governance gets taken over?
Those are the systemic risks people worry about. Another related point is client diversity. The software validators run, there are different versions called clients, but one specific client, Geth, is used by over 57% of validators.
Over half are using the same software.
Yeah, which means if a critical bug is found in Geth, well, it could potentially take down a majority of the network. It's a single point of failure risk the community is actively trying to reduce by encouraging use of other clients.
Okay, that makes sense. Diversify the software.
Then there's infrastructure hosting. Where do the computers running Ethereum actually live? Turns out about 60% of Ethereum nodes are hosted on big cloud providers, especially Amazon Web Services, AWS.
So, reliant on Amazon.
To a large extent, yes. If AWS had a major outage, or if regulators pressured Amazon, that could impact a huge chunk of the network's infrastructure.
Another centralization risk.
It is. And finally, while governance is decentralized in theory, in practice, a relatively small group of core developers and researchers has significant influence over the protocol's direction and upgrades. It's not centrally controlled, but influence isn't perfectly distributed either.
Okay, so multiple angles where centralization could creep in. What else?
Smart contract vulnerabilities. This is a big ongoing one. The very programmability that makes Ethereum powerful also means you can write buggy or insecure code. And once that code, the smart contract, is deployed on the blockchain, it's often immutable. You can't easily fix it.
Right. Code is law, but what if the law has loopholes?
Exactly. The infamous DAO hack back in 2016 was a brutal early lesson. And unfortunately, we still see major hacks of DeFi protocols, sometimes losing hundreds of millions of dollars. It's a constant cat and mouse game between builders and hackers.
So, user beware when interacting with new protocols.
Definitely need to be cautious and understand the risks. Then there's the regulatory environment. This has been a huge cloud of uncertainty for years.
Yeah, the whole is ETH a security question in the US.
Right. That ambiguity caused a lot of hesitation and fear. The good news, though, is that things have become significantly clearer recently, especially in the US.
Oh, so?
Well, the approval of spot Ethereum ETFs by the SEC was a landmark moment. It strongly implies that regulators now view ETH more like a commodity, similar to Bitcoin or gold, rather than a security like a stock.
Okay, that's a big shift.
It is.
Mm.
And it was reinforced by U.S. Congress passing laws like the Clarity Act and the Genius Act, which further helped define Ethereum as a digital commodity.
So more regulatory clarity, which is good for adoption.
Generally, yes, it removes a major overhang. However, we have to remember the global picture is still fragmented. Different countries have different rules. And past events like the U.S. Treasury sanctioning Tornado Cash, a privacy tool on Ethereum back in 2022, that highlighted how external regulations can impact the network, potentially pressuring validators or infrastructure providers towards censorship. It's an ongoing tension.
Right. Decentralized tech meetings, centralized regulations.
Always tricky interface.
Yeah.
And lastly, just plain old competition. Ethereum isn't the only game in town. There are other Layer 1 blockchains, like Solana, for example, that are designed for very high speed and low costs directly on their base layer.
So faster alternatives?
Yeah, they offer a different trade-off, perhaps less decentralized sometimes, but faster. They pose a competitive threat and could lead to a future where different blockchains specialize in different things, segmenting the market rather than Ethereum doing everything.
It's definitely not standing still. Lots of innovation, but clearly lots of challenges to navigate too. So, okay. We've covered the problem, the idea, how it works, the benefits, the risks. If you had to boil Ethereum down now, give someone that quick elevator pitch after everything we've discussed, what would it be?
Okay, elevator pitch, I'd say. Ethereum has successfully grown into the clear leader as the decentralized world computer. It acts as the foundational settlement layer for this whole new Web3 economy, backed by a massive network effect and that energy-efficient proof-of-stake security.
And what about ETH itself, the currency?
Right. And its native asset, ETH, is the essential fuel. It pays for all transactions. It's staked to secure the network. And it's increasingly seen as a core reserve asset within this emerging decentralized financial system.
The world computer and its essential fuel. Nice summary. It really is incredible when you step back and see how much Ethereum has evolved, isn't it? And how central it's becoming to so many different areas, finance, art, ownership. What's the one thing that really stands out to you, the listener, from our deep dive today?
Yeah, it's fascinating. And if you connect it to the bigger picture, what Ethereum represents is this fundamental shift towards digital infrastructure that's open, that's credibly neutral, meaning it doesn't favor any one party. It's ongoing evolution. The merge, the scaling with L2s, the growing interest from huge institutions like BlackRock.
Yeah.
It's not just about cool tech. It's really about building a potentially new foundation for how we interact online, how we handle value, how we prove ownership in an increasingly digital world.
A new foundation.
Yeah. And that leaves us with a pretty important question to think about, doesn't it? In this future that's becoming more and more digital, how much value do we as a society actually place on having systems that are truly owned and governed by their users, not by a single company or entity? And what compromises, what trade-offs are we willing to accept to get there? Something to definitely mull over.
A very powerful thought to end on. Thank you for joining us on the deep dive today. We hope this conversation sheds some light on Ethereum and its growing importance. Keep asking questions, keep exploring, and we'll see you next time.